Okay, today's lesson is on radicals. Well, what is a radical? A radical basically is this symbol right here. That happens to be a square root symbol. In other words, what number times itself would give us this number inside. There's an invisible 2 in this part right here. This is where the root goes. Okay? And so this is called a square root. Okay, if I draw another radical and I put a 3 in here, then we have what's known as a cube root. So this would be a square root. There's a 2 in here, square root. That's what you're most familiar with. And if there's a number in here, then that would be the name of the root. So this would be a cube root. Okay? And so on. Fourth root. So right now we're going to just focus on our square roots. Okay? So let's start off with how to simplify a square root. So if you're given the square root of 40 and you're asked to simplify this, you're not going to change it to a decimal. What you're going to do is you're going to look at your perfect squares over here and see if there's any perfect squares that go into 40 evenly. You're going to break this down into 2 factors. So obviously 4 goes into 40. Anything larger than 4? No. So we're going to use 4 as the square root of 4 as one factor, times the square root of 10. 4 times 10 is 40. Okay, so this is the process of simplifying, breaking the number down into 2 factors, okay, where one of them is a perfect square. So the square root of 4 is 2 because 2 times 2 is 4, and the square root of 10 cannot be simplified. It does not have any factors that are perfect squares, except for 1. And so that's how you simplify the square root of 40. Now remember, we're simplifying. Okay, let's look at another example. This time, let's involve an imaginary part. So let's say that we have the square root of negative 20. Okay, so again, we want to break this down. So the obvious factor that we want to write first is the negative 1. So we're going to have the square root of negative 1 as one of the factors. And then breaking the 20 down, looking for a perfect square. Looks like 4 again is going to work. Now, if 20 is not a perfect square, okay, then when you break it down, if you can break it down, one of the factors will be a perfect square and one will not be a perfect square. Okay? So recall that the square root of negative 1 is I. The square root of 4 is 2. And then the square root of 5, I like to put that on the end. And so simplifying the square root of negative 20, we get 2i square roots of 5. That's how you simplify. And when you're solving problems or when you're evaluating expressions, you always want to simplify your radicals before you start to add and subtract. So let's take a look at adding, subtracting, and multiplying radicals. Okay, so let's say, for example, example 1, we have the square root of 2 plus the square root of 8. Okay, so if we want to add these radicals together, we cannot do that because the radicand, the number underneath the radical is called a radicand. The radicands are different. So in this format, we cannot add them together. So what we want to do is see if we can simplify. So looking at the square root of 2, are there any perfect squares besides 1 that go into 2? No. Square root of 8, 4. So we can break this one down to its factors of the square root of 4 and the square root of 2. 4 times 2 is 8. So then we would have the square root of 2 plus 2 square roots of 2. Now, remember that there is a 1, an invisible 1, in front of that square root of 2. Okay? Since the radicands are the same, okay, we can go ahead and combine these two terms. Kind of like 1x plus 2x. We have like terms, and we can combine those. Well, we have like terms here as well because the radicands are the same. So 1 square root of 2 plus 2 square roots of 2 is going to be 3 square roots of 2. Okay, let's take a look at another example. So let's say we have the square root of 6 times the square root of 6 plus the square root of, let's go with 4. No, that's a perfect square. Let's go with the square root of 3. Okay, so notice that we have a square root of 6 times a quantity. So remember, when you're multiplying times a quantity, you want to distribute. Okay? So when multiplying, you multiply the radicands together. So 6 times 6 is going to be the square root of 36. And then the square root of 6 times the square root of 3 is going to give us the square root of 18. Okay? And now we want to go ahead and, now the radicands are different, so we cannot add. So then we want to try to simplify. So the square root of 36 is 6, because 6 times 6 is 36. And then the square root of 18, let's see if there's any factors that are perfect squares for 18. Any perfect squares that go into 18 evenly? 9. 9 goes into 18 evenly. So this one's going to break down to the square root of 9 times the square root of 2. Remember, if it's not a perfect square, you want to break it down to two factors where one is a perfect square and the other one is not. Okay? If you can't break it down, then you have to leave it alone. You can't do anything with it. You have to leave it as it is. But yes, we can simplify this because it has a perfect square factor. So we have 6 plus the square root of 9 is 3, and the square root of 2 can't do anything with that, and that's as far as we can go. Remember, we're simplifying. So that would be your answer. Okay, let's take a look at another example. Another type of problem you might encounter. We're in example 3. So let's say we have 5 square roots of 7 and we square it. So what we need to do here, we have one term and we're squaring it. So what you want to do here is we want to square the 5, okay, and the square root of 7. We're squaring both of them. So 5 is getting squared, and the square root of 7 is also getting squared. So finishing this off, we get 25. And the square cancels out square root. They're inverses of each other. And we're going to have 25 times, because this is multiplication, times, since they cancel, times 7. And 25 times 7, 7 times 5 is 35. Carry the 3, 14, 70, 175. Okay, and that would be our answer. Now, if you had a problem that looked like this, okay, you would want to do it differently. Remember, this is a binomial that's being squared. You would need to either FOIL it or use the box method in order to simplify this problem. So I want you to try this problem. You can either FOIL it or use the box method. And let's see if you can get the correct answer. All right, I'll see you guys tomorrow. Thanks for all your hard work.